everybody. Welcome. Nice to see you all. I'm here to tell you a little bit about LiveView. We are going to talk about how LiveView handles the hard parts, how it optimizes WebSocket communications with a new feature called LiveView Streams. And before I tell you a little bit about myself and before we dive in, I'm just really curious, show of hands, who has worked with LiveView before? So few people, that's so cool. So you're all just really curious about what this thing is, why it's so great, why you definitely want to use it for web development. Okay, hi, I'm Sophie. I'm the co-author of Programming Phoenix LiveView along with Bruce Tate, which is out in beta right now from Prague. I'm not just here to shill for the book, I promise. But if you have questions about LiveView more broadly, I am definitely someone to talk to. I'm also the co-host of the Beam Radio podcast, along with a group of really great people. If you are interested in Beam programming more generally, functional languages, which I'm assuming you are because you are here, you should check out our podcast. I'm a staff engineer at GitHub. I don't use LiveView or Elixir or any Beam languages at GitHub before you ask, but if you want a shoulder to cry on about Azure Event Hubs, come and talk to me. I also own a totally normal dog who can very often be found making this shape, which is very average for him to do. All right, so what am I going to cover? We are going to talk about how LiveView streams optimize client-server communication over WebSockets. I'm going to show you a little bit about how to work with streams and a little peek at how they work under the hood. This talk is primarily focused at people that are, in fact, new to LiveView. So we will look at some code, but we're going to keep it pretty high level. You don't have to be a LiveView expert to walk away with a bit of an understanding of how this works, what's so great about it, and I'm hoping an urge to learn even more. You will gain an appreciation for the very declarative nature of LiveView as a web development framework, an understanding of what streams are and how they fit into LiveView overall, and the tools that you need to dive deeper into LiveView, including a discount for my book and even a chance to win a free copy. Let's see, is this working? All right, so what is it? If you're not one of the two people that raised your hands, you may not know what LiveView even is. I'm going to tell you it is a simple, declarative, and functional web development framework. It is part of the Phoenix Web Dev framework, which goes with the Elixir programming language. Can I do a show of hands for Elixir programmers in the room? The one person that raised their hand for working with LiveView. Cool. Beam more generally, any Erlang folks? Anybody else working on the Beam? Okay, cool. You guys just came to explore something brand new, which I absolutely love. All right, so what's LiveView? How does it work? A LiveView is a process. That's pretty much it. It receives events. It maintains its own internal state. So it updates that state when it does receive events, and then it renders the state in the UI for the user. So if you've worked with processes at all on the Beam or otherwise, if you're familiar with the actor model or a gen server, an agent, a task, anything like that on the Beam or a similar functional language, you pretty much know what LiveView is and how it works because it's that simple. A LiveView state is maintained internally in an immutable Elixir data structure called a socket. So you'll hear me refer to socket and socket assigns, which is where LiveView stores its state internally. So because of this, because it is a functional framework, because it sits on top of the Beam, because a LiveView is basically just a process, it really simplifies client-server communications and makes it easy for you to build single-page web apps. And anyone who's familiar with building single-page web apps might find that appealing because very often it is not that simple. Is that going to go? Okay. Let's talk a little bit about the LiveView lifecycle. I've told you what LiveView is, very, very broad strokes, how it works. Let's get a little bit further into the details. There are two phases to the LiveView lifecycle. In the first phase, your user may open the browser. They might type in youramazingapp.com into that URL address bar and hit enter. This is a regular old HTTP GET request that gets sent to your server. Your app will render a web page in response, just like normal. And then phase 2 kicks in, and this is where LiveView really begins. The LiveView client-side code part of the library will send a WebSocket request once that initial page load occurs, and this will open this persistent bidirectional WebSocket connection. And over this open channel of communication is where all of the magic happens. This is where we begin this persistent LiveView lifecycle. So LiveView process receives an event, updates state, re-renders the portion of the page that needs to change based on the change to that state. Basically, it hangs out and looks like this forever and ever until somebody's computer explodes or melts or they decide to, stop working for the day. All right, what's so great about this? So many things. This makes it pretty easy, in my opinion, to build these really fast, interactive, real-time single-page applications. So if you're used to integrating maybe a front-end JavaScript framework with a back-end, let's say, API, if you're used to having to manage sort of the complexity and the coordination that requires, LiveView eliminates that need for you because you're writing all your code, pretty much all your code, all the code you need to write on the server side, and the framework handles all of the details for you. And on top of that, this is built on top of the Beam, so you get all of the benefits of OTP. You get fault tolerance, you get massive amounts of concurrency, you get all the speed that entails without actually having to know how any of that works, which is always nice. You also get pretty easy levers to pull to integrate your own JavaScript should you need to. So one of the things that Elixir developers and Phoenix developers were really fond of saying when LiveView first came on the scene a couple of years ago was like, hooray, we don't have to write JavaScript anymore, because a lot of Elixir developers are backend developers and we sometimes kind of poo-poo JavaScript. But what it really means, what LiveView really gives you is not you don't have to write JavaScript anymore. It's that you don't have to write the burdensome and the toilsome parts of JavaScript because LiveView is very declarative. You don't have to teach your LiveView application how to send a message to the server or teach the server how to respond to the client. You don't have to write the tedious JavaScript code to update the page in accordance with the changes described in that message. You just have to tell LiveView what to do, and you can focus on the details and the requirements of your application for your organization, your business, and your users. And that means that you can integrate all of the fancy and sophisticated JS that you want, and then you just kind of get to focus on the fun parts, if you even need the custom JavaScript, because again, LiveView bakes a lot of that in for you. Okay, so this leaves you to focus, like I said, on building that custom logic and interaction for your application. You don't have to do that sort of boilerplate of client-server communication. You never have to tell LiveView how to do something. You always only tell it what to do. Very declarative, like I said. And one of the best examples of this aspect of the LiveView framework is the live streams functionality, which is actually new. So even if you're super experienced in LiveView and you've been using it ever since it first came out, however many years ago, I think 3, maybe you don't know anything about streams, or maybe you just know a little bit about it. And that's about to change. So before we dive in and I tell you what LiveView streams are and how they work, I want to talk about the problem that they set out to solve. So what is this problem? LiveView always aimed to optimize client-server communication by minimizing the amount of data that is sent between the client and the server. In particular, minimizing the amount of data that the server sends to the client to describe changes to the page as a result of changes to the internal state stored server side in that socket that I told you about earlier. So LiveView sends only the absolute smallest amount of data to describe that page diff, and then the LiveView JS client, which is baked into your front-end code, you don't have to write any of this code yourself, will read that teeny tiny diff and it will change whatever needs to change on the page. That could be a button, a div, hiding a modal, showing something, and so on. Here is an example of the payload that the server sends to the client to describe a page diff. This is kind of junk. It's not really meant for human eyes, which again is what's so nice about the declarative nature of LiveView. You would never have to introspect on this data structure, which frankly looks terrible. You would never have to write any code that would have to pick things out of there and figure out what to change on the page as a result. But you can just get a sense here of like how small this packet of information that the server is sending down to the client to tell LiveView what to do, what to change in the UI. But even so, this is not always enough of an optimization. What if you're dealing with a huge data set? What if you have some sort of Spotify type UI and you have like a bazillion technical term songs to show your user or allow them to browse? Even small page diffs, don't really hack it when you've got huge amounts of data that you're trying to communicate between the client and the server. So before streams, LiveView did have some bits of functionality to deal with this problem. You could store all that data on the server, which is, not without its cost, or you could have used a feature called Phoenix update equals append. storing a lot of data on the server is still certainly not free, and that append feature could be a little cumbersome to work with. So this is a question that I would actually get the most frequently up until streams were invented, and now I have a really nice answer for it. If I was giving a talk or teaching a workshop, talking about the book, whatever, this was like one of the top 3 questions that people would ask me. LiveView seems great, but what about when I have a massive amount of data? What happens to my single page app then? Well, now I have an answer, and it's called LiveView Streams. So what are they? LiveView Streams let us manage these really large data sets efficiently because they are detached from server-side storage in the socket, and they're stored entirely client-side. And if you had to write any of the code to do that yourself, this would be a terrible solution, I think, but you don't. That's what's so great about the declarative nature of LiveView. The framework handles all of that for you. So what are we going to talk about next? Actually, what you're going to do next is watch me take a sip of water because I'm thirsty. I'll leave you in anticipation. Okay, we're going to take a look at how to use streams first. Again, I'm going to keep it pretty high level, assuming correctly that not a lot of you guys have worked with LiveView before. And then we're going to take a peek under the hood at the streams implementation because I want to really drive home this phrase that I keep using, the declarative nature of LiveView. I want to show you how it is that the framework handles these details so that you don't ever have to worry about it yourselves. What are we going to build? A chat app. It's so thrilling and unusual for a single page application. This is a little Slack clone that I built in preparation for this very talk. I'm actually amazed that I got it to look like that because traditionally I am terrible at anything front end, which is one of the benefits of LiveView. It's baked into the Phoenix web framework. It has Tailwind styling incorporated right into it. So even if you're like me and you have to Google like how to get 2 divs to be next to each other, you can still make something that kind of looks like a thing. Okay, first up, we're going to talk about inserting into the stream. How do we put some stream data onto the page? So we're going to use streams to store and render the most recent 10 messages in our chat room UI, such that when the user navigates to a particular chat room on the page, they'll see the most recent 10 messages. The first thing you want to do is put the stream data into socket assigns. I told you guys earlier that a LiveView is just a process, that it stores its state in an immutable data structure called a socket. Socket assigns is where that state is stored. Socket is a struct. You can think of it as a map. It's got a key called assigns, and that contains all the data that represents the state of your LiveView process. So the handle params function is a function that gets called when the LiveView process starts up, when the user navigates to the page in question. You can see here that we are responding with the required no reply tuple. No reply, and the second element in our tuple is going to be the state of the socket that we want to have represented on the page. So we're putting some other stuff into socket. I'm putting the room ID in there. Not so important here. What I want you guys to pay attention to is this stream4 function. We are inserting some data into the stream. Under a key of messages, we're going to put the last 10 messages. After you add your stream data to socket assigns, you're pretty much ready to render it. There's nothing else you have to do. This is some markup that you would find in the template for that UI that I just showed you guys. Pretty simple. It's a div. There's another div in it. We're iterating over the messages that we put in the stream, and we're showing the content of each one. Nothing too fancy there, but we are going to break this down a little bit further in a moment. Okay, that moment is right now. So we have some required structure to this markup. The first thing that we need is an outer element that then contains the stream elements. The outer element has an attribute on it called Phoenix update equals stream that is non-negotiable. The LiveView JavaScript code is looking for this thing. If it can't find it, it is not going to do a very good job of managing your stream data on the client side for you. So that's the first requirement. Second requirement is that we added, this is just a plain old HTML ID, but we are attaching what is called the DOM ID of the stream element to each, in this case, div that is going to display that stream content. We're going to take a slightly closer look at the DOM ID later on, but all I want you to understand for now is that there are 2 requirements for displaying stream data on the page such that the LiveView JS code can manage that stream data for you. We don't really need to understand the details of how LiveView uses these data points to do what it needs to do. All you have to do is say, here's my stream data, I'm rendering it now, pretty much end of story. Okay, and then it looks like this, and it's pretty. Ta-da. All right, under the hood, how does it work? So again, I really want to emphasize that to get this UI working, to manage what could be a very large volume of data very efficiently in LiveView, and to have LiveView manage it for you on the client exclusively, I think we wrote like 4 lines of code. Let's count. 1, 2, 3, 4, 6. 6 lines of code, and most of those was just HTML. That's all. That's all we had to do to get this looking so good. Okay, taking a look under the hood. So once we call that stream4 function in that callback that gets invoked when the LiveView process starts up, this is what socket assigns is going to look like. And again, a lot of this is not for our human eyes. This is instructions for the LiveView framework. But you can see that it's pretty much a map. And there's some information in this map that describes the stream data. The LiveView client-side code will use this information as a set of instructions for displaying and managing the stream data on the page. We're going to break this down a little bit further. So we added a streams key to socket assigns, which we just saw, which in turn points to a map with whatever key we decide. We decided to call it messages. The messages key in turn points to a struct. It is a Phoenix LiveView live stream struct. If you're not familiar with Elixir structs, it's a map. And it holds all the information that LiveView needs to do what it needs to do to show that data to the user, however you decide to display it, and later on to update it, delete it, manage it in whatever way you may instruct it to do. So we've got that streams key that was added with our call to the stream4 function. And we've got this messages key, and it points to a live stream struct. And we can also see in there that there's an inserts key that contains a list of the messages that we're inserting into the stream. It contains a deletes key that is empty because we're not deleting anything right now. And we're going to see, we saw earlier that in our template, we access this via the assignment. That's what it's called when you pull data out of socket assigns to display it in the UI, an assignment. It's there in @streams.messages. We can see the inserts key here. It's a list of would be 10 messages, but I cut it off. You can see that deletes is empty because we're not deleting anything. So we're starting to get a sense of the information that we're providing to LiveView so that it can manage this data for us. And again, if you never looked at this ever, that would be totally fine. I'm showing you so that you get a sense of how LiveView is working under the hood. All right, what's so great about this? It solves the problem of transferring really large data sets between the client and the server for subsequent updates if a user wants to add a new message, because after all, they are chatting. If they want to edit a message, delete a message, they said something that they really wish they hadn't. LiveView can do all of that for us with just that bit of information that we've already provided, and it does it efficiently because after that initial render, that data that we saw in socket assigns totally goes away, and that list of messages is stored client-side only. And how it is stored on the client and how to interact with that data is none of your business. That's what's so great about LiveView. So after the initial render, the list of messages will no longer be present in the socket under streams, messages, inserts. If you were to inspect it again, do I have a picture? No, we'll come back to it. If you were to inspect it again, you would see that that list of inserts would also be empty. And that list of messages would be embedded in the HTML, which is pretty cool. Let's go back. Okay, another nice thing about this. You don't have to tell LiveView how to render the data in streams. So how does it know how to do this? So we've already seen that we call stream4 when the LiveView is initialized, and we just put some data in our case, streams.messages. And the messages key is totally my own invention. You could call it whatever you want. Messages was totally appropriate for this chat app. You could call it songs if you're building a Spotify clone, and so on. Then LiveView renders the template for you. That's another thing that LiveView does for you declaratively. You don't have to tell it how to render a template in response to getting a message from the server. You just define a template and it knows what to do. And in that template, you may recall we called streams.messages. We iterated over it, and LiveView for us rendered the data that was in the socket assigns streams messages.inserts. We didn't have to do any of that. This is the declarative nature of LiveView. It's going to do the same thing if we need to update any of the messages in the stream, delete them, add 1, add 20, get rid of 100. We're never going to have to write the code to actually perform those operations. We're just going to have to provide a set of instructions to LiveView. Please update this message, please delete that one, and so on. And we're going to see some of that in action in a few minutes. But before we do, I want to take a slightly closer look at rendering because there's something a little bit odd here that you may have picked up on. So the data we're rendering is stored in socket, assigns, streams, messages. That's it. This points to a single LiveView stream struct. It's only under messages.inserts that we have that list. But in our UI, we didn't have to say socket, assigns, streams, messages, inserts, and iterate over it. All we had to do is reference these streams.messages. Much better, much more ergonomic approach, right, than having to drill that far down into it. That level of detail, like I said earlier, is none of our business. But if streams.messages is a struct, how is it that we can declare this iteration? Well, streams themselves are enumerable. And this is implemented within the LiveView Streams module, which implements the enumerable protocol for you. We're going to take a quick peek at it, but this is just out of interest. This is exactly the kind of detail that you never have to concern yourself with when you're working with LiveView. Is this what's happening? Oh, I may have... Okay, cool. So this is in the LiveView Streams module. It implements its very own reduce function. And here it is pattern matching out the content of the inserts key, which is where our list of messages happens to be. And it's calling another function under the hood, doReduce, with that list. And this is what it is going to return to us. The first element there is the DOM ID. We have an index number that instructs LiveView as to whether a message is being appended or prepended. And then we have the message itself, the stream item, if you will. This is just a very simplified look at what doReduce does under the hood. It's basically a reduction. It's taking the items out of the list of inserts, and it is returning two tuples with the DOM ID and the item. And if we wanted to inspect that list of tuples ourselves, we could do so. You could put this code in any server-side function. You could put it before the render function runs for your LiveView process, just so that we can get a sense of what actually lives in socket, assigns, streams, messages. And this is what you would see. DOM ID, messages-5, 5 being the ID of this particular message, and then the stream item itself. How this was created, we just saw a brief look at, but we didn't have to write any of that code, and we never have to look at it if we don't want to. All right, I promise you that I would tell you a little bit more about stream ID, DOM IDs rather, and what they're used for in LiveView, and I'm going to do that now. So LiveView uses each stream item's DOM ID to track that item on the page so that you can later provide the instructions to LiveView to update an existing item or delete an existing item. LiveView expects this DOM ID to be attached to the HTML element that contains the stream item, and that structure matters. If you put that DOM ID like a level up or a level below in your markup, LiveView is basically going to choke. It's not going to manage your data very well for you. So those are some caveats to keep in mind. So we attach the DOM ID to the div produced by the iteration in our for directive. We did it right here. So we can see in our iteration, we now understand why it is that we can iterate over streams.messages, even though the list itself of data is in stream messages inserts. And we can see where the two tuple that is getting yielded for each step of the iteration actually came from, because we peeked under the hood at that reduce function. So we're iterating over each message, where each message is represented by a tuple of DOM ID and the message itself. And we're attaching the DOM ID as an HTML ID to the actual item that's rendering the content. Okay, so all the stream data is stored client-side only. As soon as this page renders, there is nothing in socket, assigns, messages, inserts anymore. It's now an empty list. So LiveView has to be able to derive all the information that it needs to manage this data from the content embedded in your HTML. And that's what the DOM ID is for. It's going to use that, as I said earlier, to update or delete our stream items, our messages for us. And that's all we need to do to render those stream items. To recap what we've done so far, which actually is very little, we stored the initial stream data in socket assigns, and we iterated over it to render it on the page. That's it. That's all we had to do. LiveView takes care of all of the details for you. Everything is now managed client side. Your server side code is nice and clean, and it is very efficient to run because it's not storing 10 messages, 100 messages, 1,000,000 messages, and so on. The page is going to render this list of messages from the stream. LiveView no longer holds it in state on the server side. Oh, this is what I was looking at earlier. Once that initial page renders, this is what socket-assigned streams look like. There's nothing left in inserts, and there doesn't need to be anything there because you still have what you need to tell LiveView to update, delete, bulk insert, clear out, remove, whatever, any of the stream data, and you're not going to interact with that data directly. All right, I'll show you how. We're going to update a message with the stream insert function. We're actually going to add a new message and then update an existing message. So assume that we have a form for a new message. You saw the UI, you would type in at the bottom just like in Slack, and we have a pub/sub integration that will notify every user's LiveView around the world. When a new message is created, it will broadcast it out. So assume that we have a handle info function that's going to get all of those broadcasted messages so that if all of us were on the same Slack chat room, we would all get a message at the same time. Here is that handle info function. We are broadcasting a message that contains the new message that some user just submitted. And all we have to do to get it added to the stream is call stream insert. That is it. It's barely a single line of code. And this is what it does for us. It updates socket assigns stream inserts. It puts the new message content into that list of inserts, including, you'll see the DOM ID, and a piece of information there, an index -1, which actually tells it to append. Yes, append the message to the end of the stream, and then the message itself. And that's all you need to do to tell LiveView to add a new item to the stream. This would automatically appear at the bottom of the list of messages in the chat room. The only line of code we had to write to do that was this one. That's it. Super declarative. Okay. LiveView will re-render the template anytime anything changes in socket assigns. The LiveView client will follow the instructions that are now baked into streams, messages, inserts. It'll append the new message to the end of the view in the chat room. If we want to update an existing message in place, it is just about exactly as easy as it was to add a new message. Do I have a video? I do. Here's the feature. Is it fuzzy? No, you can kind of see. It's a little fuzzy. I'm not that excited. Yes, I am. I'm even happier than I thought. There you go. That's what we're going to build. Unsurprisingly, it's going to happen in about one line of code, just like with our addition of a new message. Same thing, we've got a form for editing a message. We've got a pub/sub integration that ought to broadcast out a message to everybody's LiveView. So everyone has a handle info function that will respond to that message broadcast. This looks almost exactly like the function that we called earlier. We're calling stream insert into the messages stream, the message itself at -1. So that's going to do a couple things for us. Because the message with this DOM ID already exists on the page, LiveView will know that it's updating an existing message in the stream. And because we provide the at -1 option, LiveView will know to update the message in its current position in the stream. But you could also give it a different instruction to maybe take it out of its position, add it to the end, add it to the beginning. That just happens not to be what we want here. This is another example of the declarative nature of LiveView. You don't have to teach LiveView how to update a message in place. We just had to tell it to do so. All we needed was the instruction regarding which message to update with the updated message struct itself. There's one last thing that I want to show you before we wrap up with some time for questions. Let's talk about deleting a message. So I've got this very advanced little red X that I'm not even going to tell you how long it took me to get a little red X to show up there. It was not great. A user should be able to click that button and the message disappears, just like in Slack. So we've got an event handler that's going to run when you would click that button. That, by the way, involves user clicking a button. The JS code that runs on the client side that you never have to write or see or even think of sends an event up over the WebSocket connection to the server. All you need is this handy event handler. And it's going to respond to delete message. It's going to find the message. It's going to delete the message. And then it's going to remove the message from the stream with this single line stream delete. And then what message do I want to delete? The call to stream delete returns a socket with an assigns that now looks something like this. You can probably guess that deletes is no longer empty. It's just the DOM ID. And that is the result of this one call. I didn't have to compute the DOM ID myself. All I had to do was tell it the actual message to delete, and this is the resulting socket assigns. This gets sent back down to the client, which instructs LiveView to remove the item with that DOM ID from the rendered list of the stream's messages assignment. And that's all you need to do to delete a stream item, like a quarter of a line of code, which I think is very cool. We tell LiveView what to delete. We do not tell it how to delete it. It's none of our business. We don't care. So as always with LiveView, the framework handles the details of the how. It handles the hard part. It handles that sort of tedious boilerplate communication between the client and the server. Actually, I did lie. There is one more thing I want to show you as a bonus before we wrap up that will illustrate something I told you a little bit about earlier, which is that LiveView doesn't mean no JavaScript. It means you don't have to write the boring JavaScript, but there are plenty of ways to incorporate JavaScript pretty easily. So with a chat app, with Slack, for example, you should be able to scroll up infinitely, go back as far as your retention policy allows. This infinite scroll back, I think, can be kind of like notoriously painful to implement in a lot of JavaScript frameworks. Certainly with vanilla JS, there's like a lot of code you have to write to get that working, even if it isn't terrifically complex. Wouldn't it be great if you didn't have to? Well, you don't. It used to be fairly easy to do this in LiveView with a feature called JavaScript hooks, which would allow you to hook into a moment in time on the page and execute some arbitrary bit of custom JS. Not terribly complex, but now it is even easier to do this kind of thing in LiveView. It's now baked into the framework itself. We have this wonderful new DOM element binding that you can add to any element on the page called the Phoenix Viewport Top element binding. You can probably guess what this does. When the scroll reaches the top of the viewport of this particular element, LiveView will send the message that you specify, and in my case I called it load more. It'll send that from the client to the server. All we need is an event handler for that load more event. This will get invoked for us on the server side if we define it. Once that scroll top has been reached, calling a helper method here called paginate messages that I wrote. We're going to gloss over some of the details, but basically the gist is get the previous 10 messages, put them into the stream. At 0 means prepend them, which is what I want in my infinite scroll back. That's it. Calling stream for on an existing stream will do a bulk insert for you, either at the beginning or the end, depending on what option you provide. It's going to leave the existing items in place. That's it. That is all you would have to do for infinite scroll back. I'm going to summarize that one more time because I think it is so amazing. Phoenix Viewport Top, one single event handler, infinite scroll back, done. You didn't have to write the JavaScript, but it's there. It's running for you. This is really just like some of the things that you can do with streams. I've just showed you the basics here. What are a few of the other things that the API allows you to do that the API supports? You can reset a stream, totally empty it out, or completely override its contents. This is pretty cool. You can limit a stream so that only a certain number of items are rendered at a time. Actually kind of essential if you're doing an infinite scroll back or an infinite scroll down, because you don't want to overwhelm the client and just infinitely add 10 messages forever and ever. You can say limit 50, and once you've scrolled back enough times that you've hit 50 messages, the LiveView client-side code will start removing from the bottom of the list. But you could also implement scroll forward so that you add them to the bottom as well, and your limit would ensure that things got removed from the top as the user scrolls down. Only a couple more lines of code to support some pretty sophisticated functionality. We're ready to wrap up. So like I said, these are just some of the basic examples of how to use streams to manage data in your LiveViews. We looked at some stream functionality under the hood just so that we could see how LiveView handles the details so that you don't have to. Streams allow LiveView to handle really big data sets very efficiently. They're very declarative, just like everything else in LiveView. You don't have to worry about the details. You don't have to worry about the boilerplate. You never have to tell LiveView how to do anything. You just have to tell it what to do, and it integrates really seamlessly with LiveView's JavaScript offerings. We got that infinite scroll back, infinite scroll forward with just a handful of lines of code. like I said, you don't have to teach LiveView how to operate. You only ever tell it what to do. Add something to the stream, update something, remove it, overwrite it, and so on. The framework handles the hard parts. And that's it.